Welcome back, Mindsetters. If you have just joined us, we are doing 2D trigonometry and we were about to get into a really nice, meaty question. So I'm glad that you guys, if you have just joined us, have joined us right now because it is the perfect time. And in case there's still people that you want to join us or you want to call them so that they can join us, please do so right now because I'm sure that they also have as many questions as you do on 2D trigonometry. Over to you.
Thank you so much, Katlego. So guys, we're going to get straight into a question, and in this question we're going to have a look at using the sine rule. Alright, so they tell you that the diagram below, and I will try and keep the diagram up as soon as we've read the question. The diagram below is a representation of a 25-meter vertical observation tower, TB, and two cars, K and L, on the road. So let's have a quick look at the diagram. So TB is our tower. We are given that it's 25 meters high, and then they tell us that K and L are two cars that are on the road. Okay, they say that the angle of depression from the top of the tower T to car L is 10 degrees. So let's have a look at that. So if we're looking down from point T to this car here, L, that angle is 10 degrees. Now remember, angle of depression, you're looking lower than you. Okay, so from the observation tower, you're looking down, so your angle of depression there is 10 degrees. And we always measure that with the horizontal axis. And the angle of elevation from car K to the top of the tower is 17. So imagine that you are a passenger in this little car here, car K, and you're looking up. Okay, so remember, angle of elevation, you're looking up. So from car K, we're looking up to the top of tower T, and they say that that angle is 17 degrees. Okay, they say that BK and L lie in a straight line and on the same horizontal plane as the tower TB. All right, so BKL in the same horizontal plane as your tower TB. Okay, so remember guys, when you get these kind of trig 2D questions, try and fill in as much information as you possibly can. And sometimes this helps you to answer the questions when you haven't even looked at the questions yet. You know, your answers just come out straight away. Okay, so let's have a look at the diagram and see what we can mark down. Now remember, the top of the tower and the base of the tower, those are going to be parallel to each other. So therefore this T, let's call it Z, is going to be parallel to BL. Okay, so they are parallel and they are perpendicular distance apart. Okay, if those are parallel and we know that angle T is 10 degrees, the angle of depression to car L. Remember your parallel lines, your fun diagram from grade 8 where you get alternate, corresponding and co-interior angles? Well, TZ and BL, those are parallel, and the angle that you get formed between those two, if we look at this angle here and angle here, angle L, those are the Z shape, that's the alternate angles, all right? So therefore, if that angle is 10, that means that angle L here is also going to be 10 because of alternate angles. Okay, let's see what other angles we can mark down. We know, remember, that TZ is parallel to BL. So therefore, if we look at the whole of T2 plus 10, so that whole thing there, that's going to be equal to angle K2. Because once again we have alternate angles, all right? So if you can cast your eye along, and I'm going to try and just draw in another line here, just in case you can't see the alternate and the parallel lines we're talking about. So it's that one, all right, and that one there. Okay, so that's just to mark off our alternate angles that we're talking about. We're talking about K2 and that big angle T there. So if K2 is 17 degrees, that means the whole of T would be 17 degrees because of the alternate angle, the Z shape that I've just marked off. So if the whole thing is 17 degrees and this little part of T is 10 degrees, that means that T2 must be 17 minus 10, which is 7 degrees. All right, so all we've done is we've marked down L is 10 degrees from alternate angles, and then we've marked down that T2 is 7 degrees also from alternate angles. If we wanted to, we don't know if we need it yet, but we can also write down the value of T1 using angles in a triangle. Okay, let's now have a look at the question and see if any of this information is going to be useful. Okay, so the first one says calculate the angle of size of angle L. So look at that, we've already done that even though we didn't look at the question. We've already shown that angle L was 10 degrees because of alternate angles to angle T. So therefore L is equal to 10 degrees. All right, the next one says calculate the length of KT. So let's have a look at the diagram. KT, that's the side here. Okay, now let's see what we've got in that triangle. Remember, if we identify, and as I said, we did this in detail last week, if we have a look at the diagram, we've actually got 3 triangles to think about here. We've got the big triangle TBL, then we've got triangle TBK, and then we've got triangle TKL. So there's 3 different triangles that we can possibly look at, all right? But if we're looking for side KT, the triangle that's going to give us the most information is triangle BKT, because we know that BT, which is your tower, is 25 meters, so we know that that's 25. We know that this angle K2 is 17. And if I'm looking for side KT, guys, what we can do here is we can use the SOHCAHTOA rules. Okay, so we can use sine is opposite over hypotenuse, cos is adjacent over hypotenuse, any of those ones. Or you could possibly use the sine rule, because we could work out angle T1. But just based on the information that they've given us, sticking with the information they've given us, which is the 25 and the 17, it's safer to use SOHCAHTOA. All right, so if we look at angle K2, let's just take off some of these markings so we can have a look at that angle. All right, so if we look at angle K2, okay, that's the given angle. Right, the side we are looking for, which is this one that's right next door, KT, that is adjacent to angle 17, all right? And then the side that we've got, or the side that we are given, is opposite. But be careful, because if you look at 17, the other side that's adjacent to it is BK. So how do you decide? Is TK the adjacent side, or is BK the adjacent side? Yes, they're both adjacent to angle 17 degrees, or K2, but remember, KT is special because it's the one that's opposite the 90 degree. And you know what we call the side opposite the 90 degrees? Remember from grade 10? We call it the hypotenuse. Okay, so the side we are looking for is actually the hypotenuse, and TB is the opposite. So what ratio are we going to use? Opposite over hypotenuse is sine. So sine of 17 is opposite, which is BT, over hypotenuse, which is KT. Right, remember we are looking for KT, so therefore we can cross multiply. So I'll get KT times sine of 17 is equal to BT, and all I've done here is I've just multiplied across. And then I'm just looking for KT, so I divide both sides by sine of 17. So KT would be equal to BT over sine of 17. But we know that the length BT is given as 25, so therefore we can substitute that in. So we get KT is equal to 25 over sine of 17, and then that we can just do on the calculator. All right, so we call up the calculator and we're looking for KT. So we say 25 divided by sine 17. And that's going to give us an answer of 85,5075. They haven't told us how we should round off here, so we're going to round off to 2 decimal places, and our answer is going to be 85,51. All right, so this will be 85,51. Okay. And it's going to be in meters because the length of BT was also given in meters. So this is going to be 85,51 meters. All right, so let's just recap. We found angle L very easily by using alternate angles. We used the SOHCAHTOA rule, saying that sine is opposite over hypotenuse to help us find KT. The final question says, let's calculate, or hence calculate, the distance between the two cars. Now hence, now you often see this in all sorts of different sections in mathematics. Hence means use what you've just done. Okay, so hence means you've just worked out KT, use that to help you find the distance between the two cars. Let's have a look at the diagram. Remember the distance between the two cars, this is K. That was car 1 and then L was car 2. So the distance between these two cars will be given by KL. So that's what we are looking for. All right. And once again, I'm just going to erase everything else that we're not using for now. Okay, so we know that the distance we are now looking for, the distance between the two cars is KL. We knew that angle L was 10 degrees. We've just worked out that side KT was 85,51. Okay, and what else do we know in that triangle? Remember earlier we showed that angle T2 was equal to 7 degrees because of alternate angles. So therefore we know T2, we know side KT, and we know angle L, and we're looking for KL. So what do you think? Which rule should we use? We've got 2 angles and a side. And remember when I started the introduction, I said if you've got 2 angles and a side, you can use the sine rule. So therefore we can use the sine rule in triangle TKL to work out KL. Okay, and I'm just going to put the working on the diagram so you can see it clearly. So we're looking for KL, so I'm going to start with KL. It's going to be KL over sine of the angle that's opposite that side. So therefore, KL over sine of 7 degrees is equal to TK over sine of 10 degrees. All right, we're going to cross multiply. Remember, we're looking for KL. So therefore, if I cross multiply the sine 7 to the numerator of the TK, the KL will be isolated by itself. So therefore, KL is equal to TK times sine of 7 all over sine of 10. Okay, and we know that TK, we've just worked it out, is 85,51. So we can put in the value of TK as 85,51. And then we're going to put this entire thing into the calculator and let's see what we get. Okay, so it's going to be 85,51 times by sine of 7, and then the whole thing is going to be divided by sine of 10. And that gives us an answer of, did I do that correctly? Sine 10 at the bottom, 85,51 sine 7, yep. All right, and we get an answer of 60,01. So therefore the distance between the two cars is just over 60 meters. It's 60,01 meters. And that's the distance between K and L. All right, so this was quite a nice example to show you a combination of using the SOHCAHTOA TOA and your 90-degree triangle to help you find a side in another triangle, then using the sine rule. Okay, so it's a nice combination of those rules. Okay, and I think at that point, cross over
ready
to
for
you.
a break? Okay, guys, so let's just take a really quick break. I can already see the activity on the page, and it's so fantastic. And at this point, if you want to ask any more questions, please ask us, because we are here to help. See you after the break.